Hello. Well, let's try to verify inverses again. And again, we are using compositional functions to verify inverses, compositional functions. So when I said it again, I said that because we already have one video on verifying inverses using compositional functions, in which we explained that for two functions to be inverses of each other, composition f, composition g of x has to be equal to x, and then composition g, composition f of x also needs to be equal to x. So for the two functions to be inverse of each other, both of these statements, this one and this one, need to be true. As soon as one of them is not true, the two functions are not inverses of each other. So let's see, in our case, will they be inverses? Let's do f composition g first. We don't have to, I'm just doing it because that's how we put them right here. This one was first, so I'm doing this one first. Doesn't really matter. So if we are doing composition like this, then what this really means is that we go into the f function, and then we plug the quotation marks, right? Plug the g function into it. So our f function is right here. So we start copying it, and then as soon as we hit an x, we need to replace that x by the entire g of x function, which is right there. So now instead of x, we would say, well, this is actually negative 1/2 x. Oops, we don't need parentheses yet. Minus 1, right? Close parentheses, and then we need to continue copying the f function, which means we need to say plus 1 here, right? So plus 1. Next step would be to distribute this 2, right? So if we distribute it, we get 2 times negative 1/2 x minus 2 times 1, and then we still have this plus 1, right? So what happens here is 2 times negative 1/2 is negative 1, so we have equals negative x, right? So this is negative x, and then this here would be negative 2, so minus 2, and then we still have plus 1. So this is equal to negative x minus 1 when you combine these two terms, right? And the requirement is that f composition g is equal to x, just x by itself, not positive, not negative, nothing subtracted, nothing added to it. And in this case, that did not happen. So our first check, f composition g of x, failed. It didn't give us x, right? It didn't give us x right there. Which means if we are sure that we've done this work correctly, which means we can conclude that they are not inverses. We don't have to even check the other requirement, because as soon as one of them is not met, then they are not inverses of each other. So again, how do we check if two functions are inverses of each other? By composition. Well, we do one of the compositions, either this one or that one. If we get equals to x, we continue and do the other one. If we get equals to anything else but x in at least one of them, then we know they're not inverses of each other, right? So we tried f composition g, we copy the f, We grab the g of x, put it in, distribute the 2, and our calculation didn't give us x. We got something different than x. We can actually even say this. Not equal, this not equal doesn't look good. Not equal to x, which means the two functions are not inverse, right? F and G are not inverses of each other, right? And again, now if as soon as we get this, we don't have to go and check anything else. They are not inverses. I hope you liked the video. If you did, click like, click subscribe, and don't forget to smile.